Hey guys, today we are going to talk about least common multiple word problems. So yesterday we talked about what the least common multiple is. It's the smallest multiple that two numbers have in common. So today we are going to just focus on the word problem aspect of it. So I would like you to have your book out. Hopefully you already do since I said it in my post. And I want you to turn to page 37 for me, okay? So get there right now. Okay, hopefully you are on page 37. If not, hurry. So on page 37, it goes over what the least common multiple is. We talked about the definition yesterday. It is just the smallest multiple that two numbers have in common. So we talked about how multiples are skip counting, so the multiples of 2, 2, 4, 6, 8. So keep in mind that multiples get larger. A lot of kids were answering factors yesterday on the formative, so you need to work on knowing the difference between factors and multiples. Multiples get larger and go on forever. Okay, so for your warm-up today, I want you to do this on your own. So it says that Ned is training for a biathlon. Bi means two, so it's a triathlon would be 3 sports. So this one just involves swimming and biking. So in his training, he swims every 6th day and he bicycles every 8th day. And we want to figure out on what days will he end up doing both swimming and biking. So you're going to use the chart below to help you figure it out. So you're going to shade all of the days that Ned swims. So we know he swims every 6th day. So the first day he's going to swim is day 6, so you're going to shade it. The next day he's going to swim. So if he swims on the 6th day, you're going to count 6 more days and he'll swim again on that day, which will be the 12th. So you're going to go and shade all the days he's going to swim. And then I want you to circle all the days that he will bicycle. So it says that he's going to bicycle every 8th day. So on the 8th day, he will go for a bike ride, and then you count 8 days, and that next day, which would be 16th, would be when he bikes again. So I want you to go and shade and circle all of those. So pause the video and also answer question B for me. On what days will he swim and bicycle? And also, I want you to answer the reflect, number 1. See if you can do that, okay? So pause the video and get that done for me. Okay, so hopefully your chart is shaded and circled. So it should look like this. Obviously yours isn't as colorful as mine, unless you use colors, but so you should have realized that there are some days that he will swim and he will bike. It's kind of like days where they overlap. So on what days will Ned both swim and bicycle? You should have gotten the 24th, the 48th, 72nd, and the 9th. So the number of days that Ned will swim and bicycle are actually the common multiples of 6 and 8. Okay, so those are all of the common multiples that 6 and 8 have in common. So for the reflect, what does the least common multiple represent in this situation? So the smallest multiple they had in common was the 24th. And the answer to this question is simply just it's the first day or the first time he will swim. That's it. And bike on the same day. Okay, it's the first time he does both. Okay, so it's the least common multiple. So for this word problem, the least common multiple word problems are very often things that are happening over and over again. So every 6th day, every 8th day, that's something that's happening over and over again. That's going to be when you're talking about multiples. So in this situation, if you would have found the least common multiple of 6 and 8 using the cake, I know they're divisible by 2, so I get 3 and 4. which 3 and 4 don't have a factor. So my cake is done, and then I would just multiply my bottom layer and my number outside. 2 times 3 is 6, times 4 is 24. So that would be my least common multiple of 24. And then if you use this least common multiple, and you would find the multiples of that, the multiples of 24 are 24, 48, 72, 96, and so forth. And if you notice, that's all of those answers there. So you could have used the cake to find the least common multiple and then found all the multiples of that. That's another way that you could have actually solved this problem instead of going and finding all of the multiples of each number. Both ways work, so whatever way works for you is what I want you to use, okay? So we're going to do a couple more together. So turn the page or look to the next page, whatever it is in your book, and we're on page 38. So the example 1 at the top says that a store is holding a promotion. Every third customer receives a free keychain, and every fourth customer receives a free magnet. Which customer will be the first to receive both a keychain and a magnet? So they went and listed the multiples of 3 and 4 because every third customer gets a free keychain. So the multiples of 3 would give you all of the customers that are getting a keychain. The third customer, the sixth customer, the 9th, the 12th, the 15th. So all those multiples of 3 are telling you which numbered customer is getting that free keychain. And then same thing for the multiples of 4. That's the free magnet. The 4th customer, the 8th customer, the 12th customer, the 16th customer. Those are all the numbered customers that are getting the free magnet. But it's asking you which customer will be the first to receive both a keychain and a magnet. So that is where you're looking for the least common multiple. The smallest multiple that they have in common, which would be 12. So you could have done that using your cake as well. 3 and 4. You should have noticed that there were not any common multiples that you could divide out. So that's when you would just go and multiply them to get your least common multiple of 12. If you wanted to know all of the customers that would receive both, then you would find the multiples of 12. So 12, 24, 36, 48. Those are all the customers that would receive both. Okay? So we're going to skip the your turn. And we are going to look at the guided practice. So the guided practice says that after every 9th visit to a restaurant, you receive a free beverage. After every 12th visit, you receive a free appetizer. If you visit the restaurant 100 times, on which visits will you receive a free beverage and a free appetizer? And at which visit will you first receive a free beverage and a free appetizer? So I want you to go and try to figure this one out on your own. I will get you started. So I would do the first one is the 9th visit, you get a free beverage. So I would write beverage, and that's going to be the 9th visit, the 18th visit, 27th visit, and so forth. I would list all that, and then the appetizer, or just our free app, is the 12th visit. So I would say the 12th visit, you get a free appetizer, the 24th visit, and so forth. Okay, so I would go and list all the visits you would receive a free beverage or a free app. But keep in mind, you're only visiting 100 times, so you don't want to go over 100. So I want you to figure out what visits you're going to receive, both a free beverage and a free appetizer, and at which visit will you receive, or the first time you're going to receive both. So I want you to try to see if you can figure that out on your own. So pause the video and see what you can come up with. Okay, so hopefully you're back with somewhat of an answer. So I will show you what I did. So I went and I listed all of the multiples of 9 and all the multiples of 12. And those are all the visits I'm going to get my beverage and my free appetizer. So I noticed that 36 was a common multiple of both 9 and 12, and 72 was also a common multiple. So I knew that I'm going to receive a free beverage and appetizer, not drink, free appetizer on the 36th and the 72nd visit. And then I have to answer the other question, which is just the first visit. And obviously the 36th visit is the first time I'm going to receive both. Okay. So I just found the common multiples. If you didn't want to do all this craziness of listing the multiples, you could have used the cake. I think some kids like to list the multiples because it like physically shows what visits. If you wanted to find the least common multiple of, 9 and 12, they're both divisible by 3. And you get 3 and 4, which do not have any common multiples. So you would do 3 times 3 times 4. 3 times 3 is 9. 9 times 4 is 36. So there's my least common multiple of 36. And then 36 multiples are 36, 72, 108, which I only went 100 times, so I don't need 108. So that's how you would get it from the cake as well. Okay? So there is another type of word problem when it comes to least common multiple that I just wanted to show you just in case it would come up. Other than the type that we just did where something is happening multiple times. You want to use your multiples if something's happening multiple times. There is something where you could have different groups of things. So in this situation, the Fulton Cake Shop sold equal quantities of chocolate and carrot cupcakes this morning, even though the chocolate cupcakes come in packs of 18. So chocolate is packs of 18, and carrot cupcakes come in packs of 12. So even though they came in different numbered packs, they sold equal quantities of the cupcakes. And they want to know what is the smallest number of each type that the store could have sold. So in this case, just like the greatest common factor word problems usually have the word largest or greatest in it, the word smallest is here. So you want to find the least, if I could spell, common multiple in the situation. So you could list the multiples of 18 and 12 if you wanted to go and figure out what the least common multiple is. I prefer to use the cake in this kind of situation. So I'm going to find the least common multiple of 12 and 18 to figure out how many of each cupcake they sold. So 12 and 18 are both divisible by 2 to get 6 and 9. 6 and 9 are not divisible by 2, but they're divisible by 3 to get 2 and 3. So I'm done. 2 and 3 are both prime. So I want my outside numbers and my bottom layer of cake. 2 times 3 times 2 times 3. 2 times 3 is 6. 6 times 2 is 12. 12 times 3 is 36. So since my least common multiple is 36, that gives me the answer to this problem. The smallest number of each type of cupcake could be 36 cupcakes. Okay, so that's the smallest number that both 12 and 18 go into. Okay, so they could have sold so many packs of each type to get 36 cupcakes of each. Okay, so that is both kinds of word problems you may see with least common multiple. I do have a couple problems in your book for you to practice today. You are doing you're doing page 39, and you're doing 3 through 11 odd, so just 3, 5, 7, 9, and 11. So those 5. And then you're also doing 13, 14, and 15. So that's 8 problems to practice, okay? So 11, 13, 14, and 15 are going to be the word problems. You can do whatever method that you want. You can either list the multiples, if that makes more sense to you, or you could use the cake method, if you understood what I was talking about, okay? I will do more examples for you tomorrow before your practice, but this was just to get you started and get you thinking about it, okay? So get to that practice. If you do want to do more of these common multiple practice, you can do 4 through 10, but it's not required. And please let me know if you have any questions. Please feel free to jump on my Google Meet if you are an online student to get a little bit of extra help, or if you just want to stop in and say hi, okay? Have a great day. Don't forget to do your form.